Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to solve projectile motion problems in a calculus class, not physics. So it's done a little bit different in a math class. So let me show you what I'm talking about with an example. The height of a rocket can be modeled by the equation h of t equals negative 16t squared plus 80t plus 96, where h of t is measured in feet and t is measured in seconds. Part A, find the peak height of the rocket and the time when it happens. Part B, find the speed of the rocket when it hits the ground. Part C, find the acceleration of the rocket at t equals 4 seconds. And Part D, find the velocity of the rocket at t equals 4 seconds. So first of all, with this projectile motion type problem, doesn't have to be a rocket, can be a rock or a ball, or basically anything that goes up and down in the air. But the first thing I would say is that I'm giving you h of t a position graph. H of t is a position graph. If you want to find velocity and acceleration, that is going to be the first and second derivative respectively. So now looking at part A, find the peak height of the rocket and the time when it happens. There's two ways I can do this. The first way I can do it is recognizing that the peak height is always going to occur at the vertex of the parabola. And if you do it that way, it's 100% correct, but I'm going to show you a different way using calculus. So if I were to actually draw the motion of this rocket in a graph, the motion would look something like this. And here is obviously the peak height. It's the vertex of the parabola, but I'm saying it's also the point where we have a horizontal tangent line. And so what really you should be saying when you see horizontal tangent, we're saying the slope, or the derivative, is equal to 0. And that's how this relates back to calculus. So in other words, if I find the derivative and set it equal to 0 and solve for t, I'm going to get the time of the peak height. So let's find that derivative. It's going to be some easy power rules here. Negative 32t plus 80 plus 0, which I technically don't even need to write the plus 0. Now, if you don't understand how I found that derivative, honestly, you should be watching another video on basic derivatives, because I'm assuming you know this already. But like I said, I'm going to set this equal to 0. I will add 32t to both sides, and then divide both sides by 32. And then I get whatever 80 divided by 32 is, which I'm going to use a calculator for this. I get 2.5 seconds. Now this is the time when the peak height occurs, which is one of the things they wanted, but they also wanted to know, what is that peak height? How do we find that? Well, you just have to plug in this time into the original function h of t. So in other words, h of 2.5 is equal to negative 16 times 2.5 squared plus 80 times 2.5 plus 96. Plugging this all in a calculator, I will get a total height of 196 feet. Now, if you're not allowed to use a calculator in your calculus class, that's fine, but I'm just telling you right now, you're not going to see examples this complicated with the math. I don't care how mean your teacher is, I find it highly unlikely that you'd have to do this without a calculator. So that's it for part A. Next, for part B, probably the hardest part of this problem. We want to find the rocket's speed when it hits the ground. So speed, we know, is the absolute value of velocity. So in other words, it's the absolute value of h prime of t. But I don't want you to get hung up on the absolute value. Honestly, we deal with absolute values at the end. So really, we should just start with the derivative. H prime of t equals negative 32t plus 80. But the problem is, if we want the speed when it hits the ground, I'm not plugging in the 2.5 I got for the last problem, because that's not when it's on the ground. That's when it hit the peak. So how do we find when the rocket hits the ground? To answer this, we do not use the derivative. You use the original function, and all you have to do is set the original function equal to 0, because when the height's 0, you've hit the ground. So in other words, we just have to solve this. I'm pretty sure I'm going to have a tough time factoring this, so I'm just going to plug in straight into quadratic formula. So if you're in calculus, I'm assuming you know quadratic formula by now, but if not, it's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So I'm just going to plug all this in a calculator and get my two results. Two results because it's still plus or minus, remember. So after I plug this in a calculator, I get 2 times -1 and +6. Obviously, I cannot have a negative time, so 6 has to be the answer. Well, I shouldn't circle that because that's not the final answer. That's just the time when we hit the ground. And in general, you should always cancel out the negative time and keep the positive time. But it also is possible for certain problems where we have 2 positive times as our answer. So what if I had 1 and 6? Which one would be right? Always the highest positive time if the question is, when did you hit the ground? So anyways, now that we have this time, remember we were looking for the speed when we hit the ground. Speed is related to velocity, which is the derivative. And now you just have to plug in 6 for t in the derivative. And when I plug this in a calculator, I'll get -112. But remember, this is a velocity. A negative velocity does mean we're going down, which the rocket should be going in the downward direction when we hit the ground. But just remember, speed is absolute value. Now is the time I take the absolute value. And that's just going to be +112. And the units for this are going to be feet per second. And so that's it for part B. Honestly, the hardest part of the problem, in my opinion. Next we have C, which was we wanted to find the acceleration at t equals 4 seconds. To do this, we need the acceleration, which means we're going to need the second derivative now. Second derivative of this is pretty easy. It's just going to be -32, and that's it. There's not even a t in there, which then begs the question, when I want the acceleration at t equals 4, where am I going to plug in the 4? And the answer is you don't plug in 4 anywhere. The answer is just -32. And as a matter of fact, no matter what time you looked at for this problem, it will always be -32 for acceleration. The units are going to be feet per second squared. And there we go. That's it for part C. Kind of a trick question. And then finally, for the last part, we want the velocity at t equals 4 seconds. So remember, velocity is the first derivative. And this time I will not be taking the absolute value because velocity can be negative. So all I'm doing is plugging in 4 for t. That's all I got to do. And when I plug that in a calculator, I'll get -48. Units are feet per second for velocity. And that's it. That's our answer. So hopefully that all made sense. These are all very common questions you're likely to see either on an AP Calc exam or a test you might have coming up. But that's how we do it. So thank you all for watching. If you had any questions, please post them in the comments section. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.